So today we'll be covering polymorphism and inheritance. This is a pretty big topic in Java and object-oriented programming, and it's also in other languages like C++, Python. Those ones also use polymorphism and inheritance. So yeah, it's a pretty good concept to know about because you'll be working with it a lot if you do decide to pursue CS. So in Java, actually here I put some of the stuff from the previous class just to get a recap of it, because a lot of that stuff will be important for what we're going to be doing in this class. So when we're writing classes, we always have a constructor like this, and then we'll have our class setting. But first off, you should have the class setting, and then you should have the constructor. The names will be the same as they are, as it's mentioned here. You can have more than one constructor. We didn't talk about that a lot because most of the programs that we'll write, they'll only have one constructor. But just for your information, you can have multiple. And then a constructor with no arguments is called a no-args constructor. So that's this first one right here because it has no parameters that are given. For methods, I put a few important points here. So when you have a method like this, a void return type means the method does an action internal to the object. Well, that's just a lot of complicated language, but it just means that nothing is being returned, or nothing is being sent back as information. Everything that the method does is done within the class. And then for this next part, values passed to the method are called parameters. We know that methods can return values or objects, we talked about how we can return a class or an object of a class. And then lastly, methods can declare and use variables called local variables. So we talked about scope previously. We talked about how you can identify where a variable will actually be able to be accessed based on which scope it was declared and initialized in. So yeah, that's a recap of classes and methods. We have fields or field variables. You can call them fields also. That's just a short name. So for fields, you can usually make them private. There's also one more keyword called protected, which we will learn about today, but usually you will make them private. Then you have the static, which means that if you decide to include static, that means that this object or this field variable will be shared by every single object of that class. Imagine every single house that we had, remember the blueprint and building analogy? Imagine if all of those houses shared one bathroom. That would actually be kind of disgusting, but in a sense that's what the field variable is. Or one store. How about that? Imagine if we had a store field variable name that gave the address of a store, and all of those houses could only go to that store, or all of the people in those houses could only go to that store. So that would be an example of a field variable. We also have final, so this means that the field is constant, which means that you can't reinitialize the field. Once you do it one time, then that's it. That's all the field variable will have. And then you also have a data type, which is your type of data that you'll be storing, a number, string, color. Specifically for numbers, decimals or integers. And then you have your name, which is something you can decide. So let's do some practice. I included some practice for objects because we didn't do a lot of it last time. So this will help us actually gain more understanding of how objects and references actually work. So let's do this one basic example. I put a few more, so let's start with this one. So first, we see that we're making a string A variable, and then we're calling it high. We're assigning it the value of high. So in our object map, remember this, we would have references like this that would point to some object in memory. So in this case we have sta, I'll just say sta for short, for string A, and then this is going to point to high, which is like the actual value in memory, right? And then for string B, this points to hello. And because we are making it a new string, because we are using this constructor, that means that it's going to point to a new object in memory. So stb is just going to be hello, like that. So stb, that's kind of like messy, but you know what that means. And then lastly, we say this, we give the statement stra equals string B. So we're assigning the value of string B to string A, which means that this reference is not going to exist anymore, and then we make a new pointer to this high variable. So what happens to this object right here? Well, in Java, there's this thing called garbage collection. I mean, in pretty much every programming language there is garbage collection, but in Java this means that all of the objects that don't have any arrows that are pointing to them, that don't have any references that are pointing to them, they are automatically like destroyed. So this is not going to exist in the memory anymore, and that's something that Java automatically does. So for something like C++, you would probably have to do this manually. I haven't looked into it, but for Java you don't need to worry about this. It's gonna be like trashed, so you don't need to worry about that. So for our next example, we have something similar. We have the same scenario where we have two strings, string A and string B, and then hi and hello. Now we know that they point to the same hi object in memory, and we have this print statement that says print the result of whether string A double equals string B. So we already know about dot equals method, right? The dot equals method checks whether the characters of the string, this string, and the string that is being compared to, it checks whether the characters are equal. But this double equals, what this does is it checks if the memory addresses of these two strings are equal. So that's why you don't often use this, but in this case we'll just see what it does. So since both string A and string B point to the same object in memory, they both have the same memory address, because this object will just be like some random characters, and the characters are a address that will be the same for both of these references, right? So this will print true because both of these point to the same object in memory. For our next example, we have 5 strings like this, but we make one string A in the regular way that we saw with these two examples, but then we make string B, string C, D, and E, and then we all say that they're equal to string A without saying like new string cheese. So what this does actually, and let me just clear this. So what this does is you'll have a string A pointing to cheese, like that. But then for all of these other variables, since you're saying they equal string A and you're using the variable name, it's going to look a little like this. You're not going to make a new object, you're saying that it points to whatever object that string A points to. So for all of these, like C, D, E, all of these are going to point to the same object in memory. This means that if you did go back and do something like this, right? If you said like string B double equals string C, that would also return true because they all point to the same thing in memory. So yeah, I hope that makes it like better for you guys if you didn't understand. And at this point, like, you should be feeling pretty good, maybe even like pretty comfortable about how this kind of stuff works, how object references work. So yeah, let's see what else we have. So we covered these 3 examples of how we can use the object maps to represent like the strings being created, and this will apply to other classes you make, right? Like coordinate in this case, like if you made a coordinate instance, if you made a new coordinate xy, then the same rules would apply here with this. So yeah, that's a good thing to keep in mind. And if you do like decide to take some class like APCSA, this kind of object mapping, it will come in handy, because in that class there's like a lot of complicated stuff to do. Like you'll be given one example of like a complicated thing is that you'll be given like multiple classes like this. You'll have like a class called super, and then super duper, and then duper, and then it gets like really confusing because all the class names are similar, and then you're making like different instances of all these classes. But the thing is, if you are able to create this map and actually keep track of everything and be organized, then it will be a lot easier, and you'll probably do well in that like question. So yeah, let's go on to the next thing. Now we'll cover like inheritance. Inheritance is like, it's like a way for us to like group different classes together and organize classes into like a hierarchy. So you know how if we have something like a grocery store, for example, right? So this is like a preview of what we're going to do, but let's say we were going to like a store, right? So if we're going to a store, how would we make that more specific? Well, we could say that we would be going to like a grocery store. So I'll just say grocery. But how could we get even more specific? Well, we could say that we're going to like, I don't know, Safeway or something. So in this sense, we have created like a hierarchy that gets more and more specific as we go to the bottom, and gets more and more general as we go to the top. So what are some other kinds of stores? Well, you could have like a hardware store, right? Hardware. And this would be on the same level as like a grocery store, in this case of this hierarchy. So it's like you're organizing these different classes by their like meaning into like a structure like that. And you could go even further, like you could say Home Depot as like an example of a hardware store. So Home Depot, that's an example of the hardware store. So now you have like this hierarchy of different classes, and that's like kind of what inheritance is. Now, why do we do this? Because we'll have like a lot of different classes, and being able to form like these relationships between them is fairly important for like different, I don't know, applications that you'll be making. So there's that. So some important like keywords and things that we'll be using when you have for this first bullet point, if you have a class that is like more general like this, like store or hardware or grocery, then like something that is more specific like Home Depot or Safeway, those are called superclasses. These more general types, like store, that's fairly general. There's lots of different types of stores. So as a result, you have like hardware and grocery. So we say that in this case, store is a superclass of hardware and grocery, because it is the class that is directly one like level above in the hierarchy of these two different classes. So it's a superclass or a parent class or a base class for those classes. And then these classes, what do we call them? Like hardware and grocery compared to store. These classes are called they're called subclasses, child classes, and derived classes. So in this case, we would say hardware is a child class or subclass or a derived class of store. In that case, Safeway is a subclass of grocery, Home Depot is a subclass of hardware, and we have all of these like different relationships that we can describe now. Alright, what's your question, Saharsh?
So like if we say that like if you only consider like Safeway, so like if you only consider the grocery store and the Safeway, so then the grocery store is going to be the parent class and the Safeway will be the subclass.
Yeah, that's correct.
Okay.
So yeah, you can just look at two of these and then identify the relationship between them. So hardware would be the superclass, and Home Depot would be the subclass. But if you're looking at a different relationship, such as the one between hardware and store, then store would be the superclass and hardware would be the subclass. So hardware is both a subclass and superclass, but it depends on what you're comparing it to. So that's important. Right, so we've talked about like how to describe the relationship between these different classes. Now we can look at like the extends keyword. So when you're defining classes like this, you can actually add some more stuff between or after this class name, and you can say extends, and then you can put the name of a superclass. So when we're defining, let's say, hardware, we would say public class hardware, right? But then we would say extends store. So you would say public class. It's probably better if I can like write more of it out. So public class hardware. Like imagine this is all on one line. I'm just doing it on two lines because there's not enough space here, obviously, but this should all be on one line. So public class hardware, and then extends store, and then you would have your beginning curly bracket, and then that's the body of the class. But what we're focused right now on is the class name and the header. So when you say extends, that means that you're making this class a subclass of this class right here, this second class name that you mentioned. So yeah, in this case, extends is it's like the keyword, like the most important keyword for inheritance, because it's what enables you to do inheritance. So yeah, there's that. For super is a method actually that you can call within the constructor of a class. So let's say we're looking at this coordinate class, right? And let's say coordinate extended some general class, like some more general class called like grid or something. So public class coordinate extends grid. So in this case, if we go down to the constructor right here, and then we say super, we call the super method right here, because super is a method that you can call within the constructor. It's not something that you need to define, it's just something that is automatically defined in Java. So you can call super in the constructor without needing to define it. So let's say you call super, and then what that's going to do is that's going to look at the superclasses constructor, and it's going to call that superclasses constructor. So that may not make like a lot of sense, like why would we need to call the superclasses constructor, but we could have like some variables, like let's say we're still looking at the hardware class, and let's say we had like some variables within the store class, like number of aisles, like num aisles, number of aisles. I don't know what happened. So yeah, let's say we declared some variable called number of aisles, and we wanted to access that, or not accessing, but rather we defined like a constructor within store called public class store, and in that constructor we are initializing the value of aisles to some variable that will be passed in as a parameter to the store constructor. So wait, let's actually do this in code, because that might be easier. So let me share my code window. So yeah, you don't have to do anything right now because like I'm just explaining, but let's say we had like a store class, right? So store.java. So we had a public class store like this. This is our superclass as we saw in our hardware and store example, right? So let's say we had public class hardware extend store, and this should not be public, because if you can't have two public classes in one file, otherwise it gives you an error. So anyways, let's say we had a hardware class and a store class, and the hardware class is a subclass for that. So why would we need to call super? Well, let's go back to that example, like private int num aisles. This gives us the number of aisles that a store will have, right? So public store, this is our constructor, like the initializing state of the object. And let's say we define like a parameter called number of aisles in, and then we said num aisles equals this. So now we're setting this field variable equal to some parameter that we can pass in when we're creating the object. Now it's going to say here, it's going to give us an error. We must define an explicit constructor because this implicit super constructor store is undefined for default constructor. So what we need to do is we need to define a constructor, so we can say public hardware. And it's still not going to go away because we need to actually like do something about this this parameter right here. Because we only have one constructor here, we need to handle this parameter. So what we can do is we can say super like this, and then we need to pass it a parameter, like let's say 7. So you notice right away that gets rid of the error, but why? It's because this method is going to call this constructor right here, and it's going to initialize this number of aisles. So in a way, like this is a way for us to access, super is a way for us to access details and like data types, or not data types, but variables and methods of the parent class, of the super class. That's why it's called super. So that's the main thing that I was trying to explain while we were looking at the example of super that was given right here. So yeah. Some other inheritance vocab is public and private because, well, we'll be dealing with a lot of access. So public and private, and then we also have protected. Protected is not on here, but that's something that we can look at. And then we have overrided versus overload. These are two different things, two different ways to describe how we write methods. So we'll be looking at all of this. We already looked at the first two, but these next ones, we'll see how we can use those. So here I defined a more general case, right? So something that you notice about this is that we have a utensil class as the main class, that is like the super class, the main super class. You also have spoon, which is a super class of dessert spoon and soup spoon, but spoon is also a subclass of utensil. Similarly, fork and knife are subclasses of utensil as well. So in this case, this is another example, but what you should notice is that as we go down, we get more specific, and as we go up, we get more general. In Java, there's actually I'll save that for later because we'll get to it later anyways. But yeah, that's the main thing you should notice, that we get more specific as we go down and we get more general as we go up. So let's go on. In this case, there's like a definition of this utensil class. So we have some field variables here. In this case, they're protected, which is important to note. But just notice that we have 3 field variables, and then we have a constructor right here called utensil, and this takes in a string and it sets some default values for these 3 field variables. So yeah, in the case of our next of our like subclass called knife, because we have a subclass called knife here that directly extends utensil, we define a constructor and we call the super method. In this super method, we give it one parameter, which is a name, and there's a comment here, name passed to the superclass's constructor. What does that mean? Well, that knife string, this knife string right here, this goes and it's set to the value of name input. And then name, which is the field variable right here, takes in the value of name input, which is knife. So name has the value of knife now. So yeah, the super is a way to access the superclasses fields and methods. So this is a way that we can access another variable. We can say super.function equals cutting. So this is where the protected variable comes in. If this was private, we wouldn't be able to say this, because private means that it's even the subclasses can't access the field variable. But since it's protected, this means that we can initialize the value rather of the variable inside subclasses, inside classes that are like more specific to this class. So since all of these are protected, we can directly change and get their values in these few classes that we have here. So yeah, that's how we're able to say super.function equals cutting, and this is going to set the value of this function string to cutting, because the function of a knife is to cut. So yeah, that's like a real world example. Now, what does extends do? We talked about this. This will give access to the superclass's methods and fields only if they're protected, as we saw with this example. It does not call this constructor with parameters. We need to use the super method to do that. And then it adds a level of generalization and grouping to the class. So with this second bullet point, it does not call the constructor with parameters. We saw how we needed to access the constructor in the superclass that has parameters with the super method. So yeah, that's what this second bullet point is saying. Now let's practice drawing a hierarchy with this code. So we kind of drew a hierarchy here already. Yeah, what's your question, Harsh?
Like if you like go back into the slides, like it had like two public classes. But like, isn't that an error? Because like the both images have like a both public classes, right?
In this slide?
Yeah, I mean even in the next slide. Yeah. No, like in the
Oh, here?
No, like back. You know, like where the images are.
Yeah. Okay. So here, this is not a class. This is a constructor because it doesn't say class here. So yeah, that might be a little confusing, but we define the classes by saying public class. So whenever we say class, that's class. And then if we don't say anything, and we just say public and then a name, then that's a method. But in this case, it's the constructor, because the name of this method is the same name as the class. So this ... technically this should be like two curly brackets, because this constructor is within this class.
Okay.
Yeah. So yeah, let's practice drawing the hierarchy. So we drew one right here, but now let's do one for this. So we have a superclass called animal, and I know this is a superclass because I can see that other classes that are more specific are going to extend this this class. So let's say animal is at the top, animal, and then we have mammal. So mammal is going to extend animal. So we have mammal, and then we can draw an arrow that points to the superclass, and then we have a human, so that's just going to be the same thing. So you have a human class, and then this points to mammal. So yeah, that's our hierarchy. We have 3 levels, and then we have 3 classes as well. So yeah, that was a pretty basic example of like understanding the hierarchy. So one more example of this hierarchy is within Java itself. So all of the classes that are predefined by Java, they're all defined within a hierarchy, and at the top of this hierarchy there's a class called object. So it defines what a Java object will be inside, or will look like in like more specific terms. So this is defined by like the Oracle developers themselves, and you can see this like in your code. If you just type like object and then create an object instance, like an instance of the object class, then you can see that it's like something that you can actually make a variable out of. So yeah, in Java the object class is the base class for all classes. In other words, like all other classes are derived from object. So yeah, everything that you know, like scanner, math, system, all of those are defined. They're all subclasses of object, because at some point like they're underneath in the hierarchy, and object is like the top one. It's at the very top. So yeah, that's a pretty good example of how like Java is object oriented. So we covered what the super function does. Well, now here's like a summary. So super calls the constructor for the superclass. How do you know that it's calling the constructor? Because it's a method. How do you know it's a method? Because it has these parentheses. Be sure that the parameters of super and the parameters of the superclass's constructor match. So that's something that we were seeing earlier, remember? So when we were calling the superclass or the superclass's constructor for knife, which was utensil, so we were saying super and then knife with parameters. This string matches this string because there's only one parameter. And same with our other example that we saw with the hardware store. And then super.doThis will call the superclass's doThis method. This is not something that we saw, but this is something that you can do. And then super.varName points at the superclass's varName variable, as we saw with like the function variable right here. But if this was private, then you wouldn't be able to do that, because private restricts the access to only within the class, within the scope of the class. So essentially super will climb up the hierarchy to find your method or variable, and calling super will call the constructor, like calling super directly. So now let's talk about the difference between overloading and overriding. So overloading, we talked about a method signature. Remember when we're talking about classes, objects, and methods, we had like a general structure for methods, right? We had the access modifier, which is public, private. We had the return type, which is like void or some data type. But then we had the name, which in this case is like the do work, and then we had parameters, which you can see here inside the parentheses. But when two methods have the same name but different parameters, they're going to be having a different signature, which means that you can define two methods with the same name and different parameters in the same class. So these two, they're in the same class, and this is perfectly okay by Java standards because they have different method signatures technically. So you have one variable or one parameter here, and you have two parameters here. So this is what's called overloading, because you're defining two different methods with two different method signatures. Sometimes it will give you an error and say that even though you have like a slightly different method, that you'll still get the error, that you're still like not like overloading, because you can't overload by, like, I think the access modifier alone, you need to change like either one of these. So you can't say private void do work and string input as another method. Like, you would have to change the parameters. And then we have overriding. So since we have covered inheritance now, we can look at what overriding is. It's when two methods have the same name but one is in the parent class and one is in the child class. And in this case, they can have the same parameters and the same signature. Actually, they need to have the same signature, because if they don't have the same signature, then it's not overriding anymore. It's actually like a completely new method. So yeah, make sure if you're trying to override something, that you have the same method signature for both your superclass and your child class. So in this case, I have the animal superclass and I define an eats method, and then I have a mammal subclass, and then I also define the eats method here. And it's giving a yellow underline here because technically there's going to be like a keyword like at override that you're supposed to put above, but it's not required, so I didn't put it in here. So now we know like what overriding is, right? It's when you have the same method within the superclass and then you redefine it and put it in the subclass. So that's what polymorphism is. It's how you process objects differently based on their data types. So let's say I went and created a new class called human that extends the animal, or that extends the mammal, sorry. And then I created a new class, an entirely new class called lion that also extends mammal, and then I created a new class called elephant that extends the mammal. So human, lion, and elephant, they all eat different things, right? So you could define this eats function differently for each one of them. But in this case, they would all have this eats method, and they would all like redefine it from some general mammal class that's defined right here. So in that case, we're processing the object differently based on their data types, because if you call like lion.eat or elephant.eat or human.eat, they will all do different things, right? Because we define them to do different things based on what each of them eat. So in that case, that process is called polymorphism, because each of those two things, or three things rather, they'll do different things even though they have like the same function, like by a naming convention. So yeah, that's a powerful thing. That's a powerful concept of object-oriented programming. So let's do some practice in the chat, actually, because you guys can like type in the chat. So let's consider this hierarchy. We have a computer at the top, it's a general type, and then we have a laptop and a desktop. So these are more specific than a computer because you have different kinds of computers, and then you have different kinds of laptops and different kinds of desktops. So all of these are classes. So in the chat, what is the answer to this question? So let's say we have a class called desktop, and it's asking us desktop are a superclass to what subclasses. So put your answer in the chat and then we'll see if you guys got it. Yeah, tower PC and compact PC. So you guys are correct about that. So in this case, because it's above these classes, and because these classes have like arrows that point to this superclass, these classes are subclasses of this desktop. So yeah, tower PC and compact PC, and that's it. So nice job. MacBooks are subclasses to what superclass? Yeah, laptop. You guys are correct. So because it's pointing to a laptop in this diagram, it's the subclass. So yeah, which is the most derived class? Computers, laptops, or Windows laptops? So this might be kind of tricky because we didn't talk about like what is the most derived, but try putting an answer in the chat. Alright, so most people are saying computer, but in this case it's actually Windows laptops, because Windows laptops are like at the bottom and they are derived from most of these classes, remember? So these classes are the base classes for Windows laptop and laptop, but Windows laptop, it's actually like the derived class. It's not the base class. So yeah, derived class and base class, you should know like the distinction between those two, because that's going to be pretty important. Next question. Some people call computers a superclass. Why does this make sense? Well, feel free to like put a guess in the chat, but I'll talk about this. Alright, so yeah, you guys are correct, because it's a superclass to another class actually. It's a superclass to laptop and desktop, but it's a double superclass to all of these ones in the third level, right? We have the first, second, and third levels. So all of these classes, they have a superclass of computer. So yeah, you guys are pretty good at this. Last question, how many classes are derived from desktop? Yeah, 2. So we have Tower PC and Compact PC. Those are the only 2 classes that are derived from desktop. So yeah, nice job. Alright, we have our tap along now. So this should be fairly fine. Like, I don't think it's going to be that bad, but we'll see how it goes. So you'll be writing 4 classes. First, make an animal class and define a make sound method that will print nothing. Secondly, create a dog class that is a child class of animal. Inside it, override the animal make sound method and print woof. Thirdly, create a cat class that is a child class of animal. Inside it, override the make sound method and print meow. And then lastly, make a main class that will make 3 objects. So you're going to have a main method inside this main class, and this class is not going to be inside this hierarchy, so it's going to be separate. What this will do inside the main methods is that it will make 3 objects, 1 for each of the classes above, and then call the make sound method for each object. So yeah, I'll give you guys, let's say, 5 minutes to work on this, and then I'll come back. Actually, how about 4 minutes, because we have another tap along also after this. So yeah, 4 minutes, try working on this, and then we'll discuss like the answer. So we make a method called make sound, as the prompt defines, and then this is actually not what the prompt says, but I'll update the prompt and the slides to include this. But we actually move the main method to the animal class, and the reason for this is because I think sometimes Java looks for the main method in the class that is defined, that has the same name as the file name. So in this case, animal.java is the file name, which is why it might have been looking in the animal class for a main method. And previously it was in a separate class called main. The main method was in a separate class called main, but I moved that to animal so that it would be able to find the main method. So that's why the main method is there. Inside the main method, we create the 3 instances of these 3 classes and then call these 3 methods. For the dog class, we have this keyword extends, and then we say it extends animal because it's a subclass of animal. And then we put this at override syntax here. So this is for people who want to like mark their code. It's not entirely required, but you can use it to signify methods that are actually being overridden more like easily, because once you have like larger programs, it might be hard to find methods that are overridden. So this will help you. So it's not required, but I just put it here. So we're overriding the make sound method, and it's called woof. It prints out woof. And then in cat, we do the same thing, but we print meow instead. So there's that. That's the explanation for the animal class. So I'll be updating the prompt and the one on the slides as well. before I like release all the resources. So yeah. Next up, we'll have the second type along, which is for this utensils class, and then we'll see how that works. So yeah. Alright, so that might have been a little under 2 minutes, but let's go over the solution. So let me share my screen. So right, we have the animal class. Now we can make our new utensil class, utensil.java. And let me get the prompt. So we have the prompt right here. So we need to make 3 classes, right? Utensil is going to have a print utensil name. So public void print utensil name. I just copy pasted the method name here. And this is going to print I am a utensil. So let's print this as a string. So that's our base class. Then create a child class of utensil called fork that overrides this. So public class fork extends utensil, and then we override it. So it's gonna have the at override keyword and then that method, and then we just change what we're printing. So that's a successful override. And then lastly, create another child class of utensil called spoon that overrides the print utensil method and prints I am a spoon. So yeah, this is going to be a copy of fork called spoon, and then we just print spoon. So yeah, in this case there's no main method that was defined, but you can see here that we have a hierarchy and we are able to organize these different methods for these different classes. So let's go back to the slides. So we've covered all of the content for polymorphism and inheritance. Let me know if you have any questions, but for now that's pretty much it for this class. If you are enjoying like the content and if you are like learning something new, then feel free to like support me like on the type along or on the YouTube recordings. Like you can like my video or you can like even donate using Zelle. But yeah, that's it for now. So thanks for joining. You guys did pretty good work today. Thanks for the participation in the chat. Like it was good to see that you guys are like paying attention and like learning something new. So yeah, thanks for joining. I'll see you guys next time. Stick around if you have any questions. I'll stay here until like 3:05, and then